Alright, rapid fire science mode. Today I'm diving into one of the most notorious troublemakers in the world of bacteria, Pseudomonas aeruginosa. Buckle up because this isn't your average germ. So what is Pseudomonas aeruginosa? It's a gram-negative, rod-shaped bacterium, found pretty much everywhere. Soil, water, even your skin. But don't be fooled. For most healthy people, it's harmless. The real drama starts when it meets someone whose immune system is down, like patients with cystic fibrosis, burn victims, or folks in hospitals. Now let's talk pros and cons. Pro? Honestly, not many for humans. In nature, P. aeruginosa breaks down pollutants and helps recycle nutrients, so it's got some eco-friendly street cred. But the cons? Oh boy. This bug is a master of survival. It forms biofilms, those slimy fortresses that make it nearly untouchable by antibiotics. It's got efflux pumps to spit out drugs, rapidly swaps genes to gain resistance, and even hides inside cells to dodge the immune system. Think of it as the ultimate game of hide and seek, but with way higher stakes. Ready for some fast facts? Number 1, P. aeruginosa is now resistant to most antibiotics. Number 2, difficult to treat strains can kill up to 40% of infected patients. Number 3, its main weapons, biofilms and antibiotic resistance. Number 4, it can survive on medical equipment, making hospital outbreaks hard to control. Number 5, it's a top cause of lung infections in people with CF. But science isn't giving up. Since 2014, researchers have been scrambling for new ways to outsmart this superbug. One big breakthrough: Professor Martin Welch's team at Cambridge found new biochemical targets in P. aeruginosa, opening doors for smarter drugs, especially for lung infections in CF patients. Clinical trials now compare new antibiotics like ceftolozane tazobactam to older ones, and guess what? The new kid is winning. Better stability, stronger attack, and deeper penetration into lung tissue. Meanwhile, scientists are testing wild strategies, bacteriophage therapy, basically using viruses that only attack bacteria. The UCSF clinical trial with phage BX004 is running right now for CF patients. And CRISPR gene editing, still on the horizon, but it's a promising tool to cut off resistance at the source. Here's a hypothesis. The next decade will see combo therapies, new antibiotics, phages, anti-biofilm agents, all working together to finally corner this bug. But the challenge is huge. Pseudomonas evolves fast, and even phages aren't immune to resistance. So scientists are building phage cocktails, but it's complicated, expensive, and totally personalized. One last jaw-dropper: new studies using zebrafish models show P. aeruginosa can go stealth mode inside cells, hiding from both antibiotics and immune cells. That's why chronic infections are so hard to clear. But with anti-biofilm molecules and improved delivery systems, hope is on the horizon. So in summary, Pseudomonas aeruginosa is a microscopic ninja. Super tough, highly adaptable, and a nightmare in hospitals. The downside? It's a major threat in medicine. The upside? All this research is giving us new weapons, and who knows, maybe the next breakthrough is just around the corner. Provided by www.lapreuve.com, source of nopal and agave prebiotics. Write us at info@lapreuve.com for discounts. Created partly by AI and humans. Despite disadvantages, there is OnePlus AI, can scrape the latest info from the global internet. Stay safe, stay curious.